Welcome back to the beginner-friendly channel here at Spring One. Hope you're enjoying all things Spring One. Last 2 days have been incredible. We've got actually a repeat offender coming up next in our presentation. We had him as our first presenter yesterday, Glenn Renfro, and with him is Elia Gopinathan, who they're going to walk you through Spring Cloud data flow, easy for me to say. And I just can't wait to hear what they have to say. So let's get right into it. Welcome, Glenn and Elia.
Well, hello, everybody, and I am so glad to see you here at Spring One. I am going to share my screen here. There we go. And so if you are interested in hearing about Spring Cloud Data Flow, you found the right place. If you're saying, you know what, back in the day, I worked with Spring XD, or I have looked at it a while ago, and I want to know what's new with Spring Cloud Data Flow, guess what? You're in the right place. If you're saying, you know what, I have an hour to burn to, let my data crunch over here, and I need to listen to something that's fun, entertaining, and easy, you have come to the right place. With that being said, let us get started. Here we go. All right. So first off is our safe harbor statement. Take a screenshot if you're interested in reading it. Basically, it's our legalese saying that what we're about to say is going to be stuff that's happening now and stuff in the future, but by no means is it. It's just for information, not to be incorporated in any kind of contract. But let us continue. Your tour guides for this walk. One is myself. I'm Glenn Renfro. I'm a contributor and a committer to Spring Cloud Data Flow, Spring Cloud Task, and Spring Batch, or whatever they need me. With that being said, let me introduce to you Elia.
Thank you, Glenn. Hi, everyone. I am Elia Gopinathan. I am a proud member of the Spring team, and I am one of the leads on Spring Cloud Data Flow.
Awesome. I'm so glad to have Elia with me today. Actually, he's leading. I'm the co-lead, so it's an awesome day. Well, let's talk about data in your enterprise. Our data comes in so many shapes. It comes in as JSON, flat file, binary. Oh my gosh, we even say XML. Dare I say yes. These things also come in different sizes, everything from just a few bytes on a stream to terabytes of data stored on flat files and databases and from a myriad of other sources. They also come in from different systems, from our newest, greatest servers to applications in the cloud, but also they come in from our systems that may be just a little old, but they still have a lot of value in them. Well, not only do we get them from our own systems, we're getting it from external systems. Things like social media. I mean, the way I like to think of it is, what if I have a social media campaign, right? And I've been, we have the big game and we've been campaigning on it, and we want to know how our people feel about our product, our services, and our company overall during the big game, or just anytime. We want to get those feeds from that social media. So what we're talking about then is event-driven data solutions, right? Getting the data, handling it the moment that it's received. If you think about it, if you will, be able to get that data and hand it off to the decision makers so that they can make the decisions quickly, or get that data immediately so that we can help our customers at the moment in which we receive that data. But we also have data that we're going to be, let's say data somewhat a little bit at rest. In that case, what we want to do is to take and pull that data in, process it, enrich it, transform it, and then once that's complete, write it out to something else, like another data source, like a JDBC data source, or even to to maybe a Rabbit MQ exchange, right? So we have these ability to write these wonderful apps, whether one, like above, the event-driven, which will cause a long-running process that just stays and runs until we say, time for you to stop, or hey, we need to update you or roll you back because we're doing some upgrades or repaving you for security. But the other below, they're more ephemeral, are short-lived. They wake up, they do their work, and then they terminate. Well, not only that, these things, once they're written, they got to be deployed to a cloud, if you will, to a distributed environment. It could be on-prem on our servers, like I said before, in the cloud, or a hybrid solution where there's both on-prem and in the cloud. Well, Spring said, all right, how can we make life easier for folks? So in the event-driven case, we would typically, we've always said, let's just go ahead and utilize Spring integration. And Spring integration is a enterprise integration pattern implementation. If you remember the book that came out on the EIP years ago, this is an implementation on it. And so we say, okay, what we want to be able to do is receive this data. And once it's received, we've done our processing on it. And then we want to take that data and write it to some kind of a transport layer like a Kafka or a RabbitMQ or even a Google PubSub or whatever, right? So in the past, and even now, I can write a Spring Boot application, use Spring integration, and again, my apps don't live in isolation. Remember, these are microservices. They're going to be communicating with other services. So again, I need that transport layer where they were able to communicate from the first app to the second app and down the line. And again, taking advantage of Kafka RabbitMQ as that messaging layer. Well, also for the ephemeral side, I can write just a Spring Boot app that wakes up, does its work, and then terminates. But if I think about it, I'm going to have a common set of reads and writes that I want to take advantage of. Well, Spring Batch helps us do that. And with Spring Batch, what I have the ability to do is it provides a set of readers and writers that I can just configure and use out of the box. These things could be like, I'm trying to think of like a JDBC reader and a Mongo writer, or even a Kafka reader to a flat file. And all I have to do is configure them. Only code I really have to write that's logic is my business logic, which I'm going to put in my process. But the thing to also remember is I need to be able to handle transactions. Spring Batch allows me to do that by just a little bit of configuration. Also gives it features of restartability. But then we also said, hey, what if on the event-driven side, what if I could build on top of Spring integration, right? And then I could just write a function. And with that function, just focus on the business problem. I don't know what messaging infrastructure I'm going to be sending my data to once I receive it. I don't know whether it's Kafka or RabbitMQ. Spring Cloud Stream gives me that ability. Spring Cloud Stream allows me to be able to write a function. Then I include a Spring Cloud Stream starter and binder that allows me to select and within my pom.xml or my build.gradle, what binder I want to hook into, or what messaging service I want to hook into. And it could be, again, the Kafka, the RabbitMQ down the line. And so what that means is when I write my code, I focus on the business problem as a function. I include that dependency, that starter dependency. Then at deployment time, I fill in properties is what exchange do I want to use if it's Rabbit? What topic do I want to use? What ensemble? Where's the ensemble at? And with that, I get this wonderful ability to just focus on the business problem and at deployment time, make that decision. The other thing that we want to be able to do is in the ephemeral side is, again, it can be a Spring Boot app, but that just wakes up, does its work, and then terminates, by schedule or external source making a call to it. And in that case, what I want to be able to do is, I launch it into our ecosystem, but when did it launch? How did it terminate? What was the status when it terminated? How do I find this out? That's when we introduce Spring Cloud Task. With Spring Cloud Task, I can add just an annotation to my Spring Boot app, and it says, it will make sure that all that information is recorded to a common place, in this case, a relational database, so that I will know what time my boot app started, what time it terminated, and what status it was. But notice I didn't take out the Spring Batch emblem here. It's because it also works well with Spring Batch. I should have left up above in the Spring Cloud Stream demo that, yes, it's built on Spring integration, so you have that full suite of Spring integration. But this leads us to our next question. What do I do when it's time to orchestrate these hundreds of, I might have a few streams, but I'm probably going to have a bunch of streams out there. How do I orchestrate these streams? Upgrade them, roll them back, repave them, check their status. Is there a common place I can be able to do that orchestration? Similarly for the task. Is there a place which I can launch the task, be able to maintain once a task is launched, know what was the status of what that it was. If it failed, can I go to one place and restart it? Well, yes, I can. It's called Spring Cloud Dataflow. Spring Cloud Dataflow provides tools to create complex topologies for streaming and batch data pipelines, and to do so simply. Hey, Elia, could you do me a huge favor? Can you come in and show them how to create streams using Spring Cloud Dataflow?
Sure, Glenn. Let me share my screen.
Thank you.
Second, let me. Okay. The development teams continuously integrate their event-driven applications or the batch applications. These are self-contained applications. We can call them as microservice applications or independent applications, but they know how to connect those applications together. Like, for example, if they are streaming applications, then you would configure their destinations to connect to the messaging platform. So if you're using Kafka or RabbitMQ, you would provide the configuration required to connect these applications to a Kafka topic or RabbitMQ exchange. So in case of batch applications, you would use Spring Cloud Task to extend the features that Spring Cloud Task provides in running those applications. But these are continuously integrated applications. So you create a artifact, which could be a Maven artifact or Docker images, right? Once you have those ready, then you are ready to deploy them on the target environment, which could be Kubernetes or Cloud Foundry or your target platform. And this is where your configurations are getting into runtime properties. So based on your configurations, your applications are deployed in a distributed environment, and they know how to connect to the messaging platform in case of streaming applications. For batch applications, you could trigger them or manually launch those applications with a set of properties required. But like you pointed out, Glenn, this is not like when you handle like hundreds of thousands of streaming applications, and when you want to group them together, you need a centralized layer to manage these applications. For that, so we have Spring Cloud Dataflow to do the orchestration part. So here, from continuous deployment, we are going towards continuous delivery of the applications. Once you have those self-contained applications developed, you register them in Spring Cloud Dataflow. Getting Spring Cloud Dataflow aware that of your applications, and then Spring Cloud Dataflow provides you to construct streaming pipeline based on your individual applications, right? So you have an option how to connect these applications together to form a streaming pipeline, or how to construct or how to compose your task applications by forming a workflow. And then once you have that ready, so you can continuously deliver those applications into the target environment. Not only delivering those applications, you can continuously monitor them. And once you have them deployed, it's going to look like similar to how you deployed previously, right? So Spring Cloud Dataflow acts as this centralized layer where it acts as a middleman, where it provides you these features of constructing the streaming pipeline or composing the workflow orchestration, and also monitor and manage them in a secure way. So with this, let's get to a demo. And for this demo, we're going to use the use case where we have a couple of streams, and our main stream is ingesting the purchase transactions into database. And this is the same use case that we discussed in yesterday's keynote. And from HTTP source, we are ingesting our user transaction events into database. And from the same destination, we are actually connecting to a parallel stream by tapping into the same destination and creating a parallel stream that filters the incoming transactions and make the credit card transactions available into MongoDB. And my domain or the test data looks like this, with the purchase transactions and the number of clicks the user took to complete the transaction. Let me switch to my Dataflow server setup. And I have, similar to my keynote yesterday, I have the Spring Cloud Dataflow setup on Kubernetes. And instead of RabbitMQ as the binder, I have my out-of-the-box applications registered using the Kafka binder and them. Since I'm going to use Kafka as the streaming platform in this case. But if you have your own applications, you can go here and register your application. Like I said, this is where you will let Spring Cloud Dataflow know that you want to register these applications. And here you can say what type of application you're registering. In case of streaming applications, you can register source, processor, and sync. And for batch or task applications, you register your task applications. And you can register a Maven artifact or container image. Once these applications are registered, these are ready to be created in your streaming pipeline. So here I'm going to the streaming editor page where all the applications that you have registered are available to be, for us to construct the streaming pipeline. Let's see. So now we've got all the applications available, and let me see. So I want to have a HTTP source and JDBC sync. And now these are the self-contained applications. Those are developed by the individual development teams. And now you're constructing the streaming pipeline from HTTP source to JDBC sync. What this means is that you're actually saying, I want HTTP source to produce events to a Kafka topic where JDBC sync would consume from the same topic. And the pipeline here represents the messaging of the streaming platform that you have configured. In this case, we are using Kafka. And for the same destination, we're going to tap into the data. And let me pull over a filter application. And from the same destination, I'm tapping into the data and ingesting the data into a filter processor and get that data available in MongoDB sync, right? So this is where Spring Cloud Dataflow provides you the way to construct the streaming pipeline of the individual applications that you have already created. And now here you can specify the individual application properties and create those streaming pipelines. Once the applications are created, I have these applications created already, and I have deployed them as well. But I want to show you how you actually specify the deployment properties. So once the applications are deployed, so you'll get the summary view of the applications and the individual applications and their properties as well. So you can update an existing stream that is already deployed. So this is going through the same flow of the deployment of the stream. And I just wanted to give you an idea of how you can specify the deployment properties. The deployment properties are specific to the platform. Since I am on Kubernetes, I'm going to specify Kubernetes specific platform properties here. For instance, for HTTP source, you can say, I want to enable load balancer, right? So I have already set that up, so this is available. Let's say you wanted to specify a pod specific property or some resource limits, etc. You can specify them here. And for JDBC sync, I have given the config map because I don't want to specify the database specific configuration or connection properties at the time of stream creation. So what I'm going to do here is that I have already got a config map associated with MySQL database, and I just associate this at the time of deployment. And like I said, this stream is already deployed. Remember the fact that once a stream is deployed, every stream is versioned. So I have got the versioning of the streams controlled here. So in case if you wanted to continuously deliver your individual applications, let's say you got a bug fix of your individual application. And in that case, you would register that application in your app registry page and make that available when you update the stream here. So here, I can go here and say, I want to update the stream with the new app that I registered recently. I can choose that version here and update. In that case, the stream would be versioned with that application change. Now we got our stream up and running with the set of deployment properties and application properties. And we have also configured Wavefront to monitor the streaming metrics, etc. But let's post some events to see how the streams work. And I'm going to go to the command window here and say, so I have set up the MySQL and the MongoDB databases here. So those are empty now. And my test data looks like something like this. So since I have enabled load balancer, I have a public IP to post the events, and I'm posting some test events to the HTTP source that we have deployed. I'm going to post the events here. And now as these events are posted into HTTP source, I expect all the events available in my purchase orders table. Now I got all the transactions here, and I want the MongoDB to have only the credit transactions. Let me switch to the Spring Cloud Dataflow dashboard once again. And here you can see as we posted the records, let me go to the graph here. As we posted the records, all the transactions went to the JDBC, and the filtered records of credit card transactions are available in MongoDB. The beauty of Spring Cloud Dataflow is that once you have streams up and running, I can run my task applications or batch applications on top of the data that we have ingested. Glenn, could you show us how that is possible with Dataflow?
Oh man, you're giving me too much power, dude. I don't know. That's a big responsibility. Well, first thing I'm going to do is I'm going to share my screen. So the first thing I'm going to do, per popular demand of our audience who has said they can't see. So I'm going to zoom in. Woo, look at that. So these are, if you wanted to take a quick look, let me move this out my way so that I could see better. Whew, there we go. We could see a little better what Eli was showing. And here is the kind of the descriptions that what he was putting together. But now it's time for tasks. So let's go and think about what can I do with this data? Well, first thing I want to do is I'm going to create a couple of tasks. Okay, first thing, I got a purchase order table. So with that purchase order table, what I want to be able to do is to create a purchase order report, something that will read from the purchase order table, and maybe do some, create the calculations and kind of just give us a good total. So let me go ahead and put that in there. Oh, by the way, I've already pre-registered these apps. The apps that Elia just showed you came in free for Spring Cloud Dataflow because we provide you like 60 out-of-the-box apps. Well, these are ones I wrote and register with Dataflow. The first one, the purchase order in this case, actually is a Spring Boot app that's utilizing Spring Batch and Spring Cloud Task. And it's going to read data from using the JDBC reader provided by Spring Batch, and a writer that I provided that's going to write it to the log. I'll explain later why I chose to write it to a log. So in this case, after the PO report is complete, I want to go in and I want to run another task. It's called credit finance charge. And in this case, it's going to read the data that Elias stored in the Mongo table. And it's basically the purchase orders that had a type of what? Credit. And what I want to do is enrich that data and put like a finance charge on it, and then store that out into a relational database. Again, I'll be using Spring Boot, Spring Cloud Task, and Spring Batch. And I'm going to be using Spring Batch's Mongo item reader as well as the JDBC item reader. So I'm going to pop that in there, credit finance charge. And lastly, you see I'm using some different symbols and I'm typing where Eli was doing drag and drop. I'm going to show you a little feature that Dataflow gives you. So the last one I'm going to be adding is the Slack alert. The Slack alert is a little different than the previous two. Let's roll over there so you can see a little better. Notice as I was typing that it was populating this diagram down here. And if I go in there and I make a mistake, it says, Glenn, you don't know how to code. And guess what? We all know I don't know how to code. So I need all the help I can get. But we see that it created this graph. And in this graph, what we see is that I have a purchase order report. And as soon as it's done, it's going to take and run the credit finance charge and a Slack alert at the same time. Going back to what I was talking about, the Slack alert. The Slack alert is a Spring Boot app that is going to that uses Spring Cloud Task, but not Batch. Again, I want to kind of show you that demo that you can run batch applications that build on Boot. I can run ephemeral microservice apps that are built on Spring Boot. And again, if I'm running a Spring Boot app that's using Spring Cloud Task and Spring Batch, is that a microservice? Why, yes, it is. It's just ephemeral. So once I've done this, I'm going to go ahead and click the Create Task button. And I'm going to name this Spring 1, let's say A. Yay, A. And we're going to create that task. Now, I'm going to have to zoom out, folks, just a little bit for about a second. And I just want to show you the full screen. I know, you can't read it that well, but it's OK. But what we're going to do is you're going to see where I can actually go in and launch this. So we'll go zoom here and see me press this beautiful button. And then we're going to, I'm sorry for the pan and scan here, but let's go zoom out just a little bit. So in this case, at the time I launch it, I can actually go in and place in arguments of how I want my app to, what arguments do I need to be able to run my my task. Notice something else. I should go back. I can run an individual task. I can run just a Spring 1, the PO report by itself. But what I can also do through Spring Cloud Dataflow is create composed tasks that allows me to create a composition or a workflow of tasks. So what I can do with Spring Cloud Dataflow, and I think I called this one S1A. Yeah, I did. I'm sorry, a little disjointed there. I'm so excited. Could you not tell? And what I'm going to do is I want to place some command line args here of how I want it to run. And I'm going to put in some properties. I'm going to spend just a moment on these properties that I'm going to add here. And you can tell I'm doing the favorite developer tool. I'm copy and pasting because I don't want you to see some of the data I'm putting out here. Why? Well, in this case, for the Slack alert app, remember, there's a Slack alert that's going to launch. It's going to read the purchase order table. And when it reads the purchase order table, if there's a quantity greater than a certain amount, it's going to send a alert to my Slack table, or sorry, to my Slack channel that says, hey, people have purchased for this given item a quantity greater than a fixed number, right? So I want to be able to do that. But in order for me to do that, I need to tell it where the RESTful API I want to send it to. So I have created an app property here for Spring for my Slack alert. Now, I've also have the credit finance charge that's going to be hooking into what? Mongo. And since it's hooking into Mongo, I have all the Mongo configuration to be able to connect to the Mongo in a config map. So at deployment time, I want to set a deployer property for my credit finance charge app right here that will get that config map and get that data, or sorry, get that configuration data from that config map. With that being said, I'm going to turn around and launch. And we're going to wait, launch. There we go. All right, so now we successfully launched. Let's look at just a little bit of code. And so I'm going to do that. I'm going to go back to my IntelliJ. And we're going to look at the credit finance charge app. In this case, I've got it. And in this case, we called it the batch Mongo application. It's a sample. And after this talk, I will post onto my GitHub account these. Actually, I'll do it afterward and show you where all this good stuff is at. But at the top of my configuration for my Mongo app, I heard a lot of, success. I just heard my Slack chat kick off saying everything came through. I have enable batch processing. And this says I want to create a batch application. The other is enable task. That means I want this to be a task. I would need to record all this execution information somewhere. And then we start digging into the actual application. Notice that I'm taking advantage of the Mongo reader. Again, it's just a lot of good configuration, right? And we get the Mongo template using what? The Spring Boot starter for Mongo. It comes in pre-populated. You can set the properties of how you want it to behave. We are also going to be setting the collection, what collection we'll be pulling from, and I got that from properties, and also what query will I be using to acquire that data. So with that, I can go to the properties, and we can see that I'm getting from the purchase order collection, the one that was created by Laya, and then we can see that the query is nothing. It just says, return me everything from that collection. But similarly, the item writer, again, also uses a builder, much like the Mongo above, where I can go in and configure. It uses a data source, and we can see that we're column mapping, so it knows which data to pull out of the map. I'm using as an exchange media here to how to insert it into the table, more specifically into the query or the insert statement that I have. And that insert statement, again, is in my properties here. and just set here. The only real code I wrote beside just those two little bits of configuration is this right here. And it's where I'm just going in and doing that basic calculation, pulling the data, the amount, the quantity, applying a finance charge that's configurable, and then inserting it as a transaction fee. The one other thing I wanted to show you is I'm setting up my step. In my step, I'm setting up the chunk size. So it says after a certain number, I want you to commit the transaction, right? And it's right now set to 10 per my properties over here that we see the chunk size is 10. Now that we've shown you all that good stuff, let's go see what the results were. The first thing I want to do is I want to go to this right here. And we see at 12:33 Eastern Time, I received a bunch of Slack messages. I had them set fairly low, saying the quantity of this was 2. Now, if we go back to here, and we're going to go to our tasks, and we want to look at the executions. What happened during my execution? Well, the first thing is, let's start from the PO report. Remember, I had a writer here, and the writer, in turn, was just going to write that report to the log. There's a couple interesting things here. The least important, believe it or not, in this case, it's not necessarily the business stuff. We see that it worked. That's great. But notice I'm showing you a log in its entirety. Its beauty, oh, how magnificent. Remember, Elia and I are running this on Kubernetes. This is stuff that's in the pod, right? I can go to data flow and get a full status of how my task execution behaved afterward. I can even view the log. And I can see all the arguments that were passed in to make it successful. The sensitive data is redacted. I can also see the properties. Again, sensitive stuff redacted. But now, there's something else here that's very valuable. I can dig in on a job. Remember, this is a Spring Batch job. And from a Spring Batch job, zooming out, I know y'all probably going, man, he's zooming in, zooming out. I'm going to have a headache. I'm sorry. But in this case, we could see that from that job, I'm going to zoom in right here. We see that we have the ability to go view the steps. And we see that for that step, we did 18 reads, we did 18 writes, we did 2 commits. The run duration was an amazing 1 second. Woohoo! Talk about long running app. But I can also drill into a little bit more detail. I can actually go view the step information and get all this information. So what does this mean as a user? First off, it means that with Spring Cloud Task, remember, I can capture that exit code. I can view that exit code. Wrong click. Sorry, meant to click here. Go to executions, Glenn. You're in a hurry. There we go. I can get all the stats of what happened, but I can also capture what? That exit code. If there was an exit message, what was it? I can find out if there was a problem. What was it that I need to look at? So we get all this great data from Spring Cloud Data Flow. Now, before we head out, did my credit finance charge actually work? Well, I have this high-tech tool, and you can see I just truncated the table before, and I have been kicked out. Oh my gosh, I was kicked out. Did it actually work was what I was trying to show y'all. I'll give it a second to see if it'll tie in here. The answer is yes, it should. Okay, you can do it, MySQL. Yay! So we're going to tie into MySQL. Okay. There we go. And we'll say splat from credit transaction. There we go. And we see the results are there. So we see that all levels of that workflow, or what we call a composed task, worked. But there's two more things I need to show you, and then I promise to give you back Elia, okay? All right, with that, let's go back to the tasks, and we see that we can go back to the task here. And I can do 2 more wonderful things. One, I don't have to always launch it by hand. Well, I can have a RESTful API that's available to Spring Cloud Dataflow and launch things through the RESTful API, which makes it really powerful. I can also schedule a task. So with the task scheduling feature, I can say S1A here, and we'll call it schedule. Let's be original, right? Or actually, I called it, it was S1A schedule. And I can put in a cron expression, right? 0, and say at 5 o'clock every day, run this workflow. And guess what? Dataflow will say, okay, I've just scheduled this with our contact jobs on Kubernetes, and I'm done. And I can check my status of my schedule here and see that I have it and it's available. But always remember, how do I know where to go check whether to execute or not? I can click the executions. The last thing I want to show you on this is I can actually go for any of the executions, and I can go in and view through Wavefront what were the metrics of my executions, what happened, how did it behave, how long did it run. All that good information is available through Wavefront. Now, to get back to something that's very important, what's coming next? So let me go here. I apologize for showing you that. And we will play from, let's go to here. Play from current slide. There we go. So we're going to offer you in Spring Cloud Tasks, the next version, this is what we're shooting for, is what's called single-step job auto configuration. If we remember, when I had that batch job, remember I had to do some configuration. It was super easy. The builder was there for both the reader and the writer. But you know how I say, Spring just can't leave good enough alone. We want to make it easier for you. What if all you had to do was add a dependency here, Spring Cloud Starter single-step batch job? Then you could go in this case, I'm doing a cursor reader, I'm doing an item reader and writer, and I set these up using just properties. That means I don't have to write any of the reader-writer configuration code. I do it through properties. Again, this allows me to focus on what? The item processor. Just that little piece of code. Every other part I could set through configuration, like even the chunk size. Now, I'm going to turn it over to Elia, and Elia is going to tell you about what's coming up next on the stream side.
Thank you, Glenn. I'm going to share my slide here. Okay, so Spring Cloud Dataflow team has recently released a 2.6.1 release, which comprises of some of the improvements on task, the way we handle the task applications, and ability to launch task applications across multiple platforms or scheduling them as well. And the 2.6 line also has got features like getting the compose task runner as part of the Spring Cloud Dataflow itself. And most importantly, we moved some of the out-of-the-box applications into functional-based applications. And Sobi and David from Spring Cloud Dataflow team have been writing serious blogs about how you can make use of this functional model to convert your applications and make them available or orchestrate them in Spring Cloud Dataflow. And we also added a wavefront monitoring support in this 2.6 release, and the Helm chart is now using Bitnami for Spring Cloud Dataflow as well. Go to the next slide. Okay, now Spring Cloud Dataflow team is pleased to announce the commercial offering of Spring Cloud Dataflow for Kubernetes. We just have released 1.1 GA on Spring Cloud Dataflow for Kubernetes. This is the commercial version, which is built on top of Spring Cloud Dataflow OSS, and we have a dedicated Pro server and Pro dashboard UI, which we had just released. And there is a packaging support which contains the certified container images of the Spring Cloud Dataflow components like Spring Cloud Dataflow server, Compose Task Runner, and the out-of-the-box applications and Skipper server, etc. And we also provide the relocation of images into your private container registries. This would be useful when you are working inside the air-gapped environment. And we also provide a way to provision your Spring Cloud Dataflow components right from installation to upgrading of the upcoming releases. More importantly, we are providing MultiIO Stream DSL support in Spring Cloud Dataflow backend as well as the stream editor. I'm going to quickly switch to a demo on showcasing how we can actually do this. And so before that, let me show this, the use case that we had. So here we constructed a couple of streaming pipelines, right? And we had our HTTP source ingesting the data into JDBC, JDBC-backed database. And we have a parallel stream that actually tapped into the same destination, right? In this case, my HTTP source has a single output, but this HTTP source is configured to use or connecting to a single destination on the messaging platform. In this case, we configure to use a Kafka topic. But how about having HTTP source sending the events into multiple destinations? Or how about having this JDBC sync receiving inputs from multiple destinations? That's what we are supporting from the MultiIO DSL. I'm going to switch to the demo part here, and this is the dashboard Pro version we have. I hope the fonts are visible now. I'm quickly going into the streams creation page where I'm going to demonstrate some of the multi-IO capabilities. And I have created some applications here along with the out-of-the-box apps. And so similar to the HTTP application, I added a HTTP purchase order source, which has 3 outputs. So here, each output is bound to a specific destination in the messaging platform. So here, we're using Kafka, so each output is connected to a specific Kafka topic. So a debit transaction would go into a specific Kafka topic that we configure, and credit would go to its own Kafka topic, and cash transactions would go into its own Kafka topic. And let me pull the JDBC sync here. And in the previous case, we had a single input to JDBC sync. In this case, I can connect multiple destinations into the same sync here. As you can see, this demonstrates how you can actually merge multiple destinations output into single consumer sync. I got the same stream created and with pointing to multiple destinations. And let me pull the filter model like we had before, right? In this case, I don't even need a credit filter because I already have only the credit transactions coming out of from this destination. So I can just pull my MongoDB sync and have this output going into this MongoDB sync directly. I can still make use of the tap. And it is important to understand the difference between tap and having multiple outputs. A tap is on a single output, while the outputs from an application is different. Like in this case, HTTP source produces multiple outputs, and each output is configured to a specific destination. And I'm having multiple outputs from a single output here. In this case, credit transactions are going into JDBC sync. At the same time, I'm tapping into the same output and getting that transaction into MongoDB. Let's say I have a case where I'm already having my Kafka topic pre-populated with some information, say user regions, right? We know that this transaction information contains user clicks information. So I want to compute some data by combining number of user clicks per region. And this is especially useful when I'm merging inputs from multiple destinations, right? Like now I have a processor, and which is a Kafka Streams processor, which gets multiple inputs. In this case, a K-stream and K-table, and K-stream is coming out from, let's say, credit transaction. I'm just connecting all the credit transaction user clicks, and then getting the user region from K-table, right? In this case, my Kafka Streams processor has 2 inputs, and processing them in a functional model here, which I can showcase here. So I'm going into my IDE. As you can see here, I have implemented a by function where I'm combining a K-stream and K-table and doing a map reduce operation on top of it and producing the result as K-stream, which is the number of clicks per region. And these are all possible with this multi-input capability. In this case, this transform processor has multiple input, and this HTTP source has multiple producers. And this is what we support in the dashboard of Pro Server. And let's see, so I can connect the output of clicks per region transformer into another sink, right? And I can also tap into this data and provide some complex streaming topologies. Let me go back to the slide here. Okay, so from the single output, single input destination bindings into multi-IO support in the Pro server. And along with that, so we are working on some more enhancements into multi-IO support. And remember, we discussed the fact that application registry is where we will let the data flow know about all the applications that we have. And now we are working on natively integrate the container registries where you have, let's say you have a private container registry and you want those applications that you have already populated in those registries to be available in Dataflow automatically so that you can do this continuous delivery from the private registry. And as Glenn pointed out, we are also building out the single-step batch auto configuration support in Dataflow, and we will have a dedicated dashboard UI for single-step batch job in the Pro server. On the OSS side, 2.7.0 is in the works, and Spring Cloud Dataflow team is actively working on redesigning the dashboard based on VMware Clarity design system. And we're also working on providing observability support on streams applications. And and the single-step batch support, as Glenn mentioned. If you want to learn more on Spring Cloud Dataflow, and we have a dedicated site for Spring Cloud Dataflow, and you can actually see that the contents in Spring Cloud Dataflow, it's right from the documentation to, let me open the document here. Apparently it's opening in the other window here. Let me see if I can pull back. Okay, so here you can see the documentation right from the installation of Spring Cloud Dataflow on various target platforms. If you want to play on local, you can do that, and then Kubernetes and Cloud Foundry installations, and right from the architectures on how you can develop your streaming applications or batch applications, and some of the features, on streaming and batch. And we also got some recipes covered in there. And yeah, feel free to reach out to us if you're interested in contributing or getting to know about any of the features or recipes discussed here. With that, I also would like to know, I'd like to point you out on the upcoming session that we have. Let me share my screen. Go to the next slide here. Okay, so we have the dedicated session for Spring Cloud Dataflow's real-world use case. One of our Spring Cloud Dataflow customers, Penske, is presenting how Spring Cloud Dataflow can be used to process IoT scale event stream processing. So it would be really exciting to watch that session. And thank you once again, everyone, for listening to our session. And Glenn and I will be there in the webinar to answer your questions. Thank you.
Thank you, folks.
Well, thank you so much. That was really wonderful. It's always nice to have you, Glenn, and Ilya. Welcome to the beginner-friendly Spring channel. If you have any more questions for either Glenn or Ilya, please head on over to the Spring One Slack channel. Check out the beginner-friendly section, and there will be a Zoom link posted by our good friend Yvonne, who will send you off to a Q&A where Glenn and Ilya can answer any more questions you might have. And we will have another presentation 5 minutes past the hour. So just stay with us or enjoy the rest of the event, and we'll see you back here at the beginner-friendly Spring track at Spring One. See you soon.